Good morning, everyone. It's only morning for us. You could be watching this at night. I'd like to introduce you to Dr. Paul Dickinson. We're going to have a fantastic conversation today. As you all know, AII, the Alliance for Innovation and Infrastructure, is the only nationwide public policy think tank that's dedicated to infrastructure. What we look to do is bring interesting conversations, high quality, original, and impactful research, educational material, and outreach to improve the infrastructure landscape and all of those interconnections. The conversation today is going to focus on exactly one way to do that that maybe a lot of people aren't thinking about that can add a lot of value immediately and set us up for future success. Dr. Dickinson, I will turn it to you and let you introduce yourself.
Benjamin, I really appreciate you inviting me on today. I'm looking forward to this conversation. As I learn more about your organization, I look at the synergies with what we potentially can do together. I'm super excited. So I'm Paul Dickinson. I've been in the materials world and the fiber optic world for about 35 years. It's funny, I was reflecting on this just this morning. It seems like I've started out at the molecular level and I keep expanding, and now I'm focusing on the city level. So I'll tell you a little bit about that. So my background is a material scientist. I'm a polymer scientist. I watched The Graduate one too many times, and got a PhD in that. But I've been a telecom guy for many years. I was with Bell Labs. I was with Lucent Technologies, OFS. Some of you out there may remember these organizations for 23 years, and working on basically telecommunications and broadband. And I've watched fiber to the home grow from nothing. And, isn't it crazy? We're putting fiber to the home to now it's ubiquitous, and we need to have this everywhere to reduce the digital divide. The last 11 years, I've been the director of business development for Duraline, which is also related because Duraline makes these conduit pathways that go under the ground and aerially, where the most of the fiber optic cable is put inside for a wide variety of reasons we won't get into. So we have this infrastructure background that I've been focusing on for 35 years. And now we're finally at the culmination of what we're going to talk about today on what else we can do with this infrastructure background. In addition to Duraline, I'm the chairman of the board the last 2 years for the Fiber Optic Sensing Association. And I'll tell you a little bit about that. We're a nonprofit, as you guys are, formed in 2017 in Washington, D.C. And we focus on the awareness of a technology we're going to chat about today, which is called distributed fiber optic sensing. And so the synergies, again, between your wonderful organization and Fiber Optic Sensing Association are really quite amazing. The overlap's tremendous. And I'll start there, and then we can dive into wherever you want to go, Benjamin.
In addition to defining fiber optic sensing, which would be a fantastic start, I'd love to just talk about what existing infrastructure is out there that we can leverage, think about using, and I think fiber is out there. So, introduce that, and maybe let's have a conversation about how we can leverage what's already in the ground and above ground.
So I know you know this, maybe most of your audience knows this too, but infrastructure takes on a wide variety of forms, right? So infrastructure, in my mind, is a lot of utilities, gas, water, electric, all the things that we don't see either under the ground or aerially that are keeping our societies running. What's exciting, well, one thing I'll mention is because these have been put in for many, many years, many are running well, many are getting old, and many are not up to the standards and the needs for our society going forward. And I'm sure we'll talk about that later today too. So other nonprofits that I've worked with, like the Common Ground Alliance, I know you know them very well. They talk about the need to build out utility infrastructure, telecom infrastructure for all the reasons we know, and how much damage and life safety issues occur when that happens. Mm-hmm. So the records, the last thing when a project's built, the last thing that really is documented is where it is. And so we usually, sometimes the money runs out and they never get around to putting in the as-built information. Yeah. So when you're feverishly working to put out a telecom in a city, whether it's open access or you're a tier one building out, you sometimes don't know where other utilities are and you hit them, you damage them, or vice versa. So there's all kinds of issues going on associated with the infrastructure. Now, telecom infrastructure, which has been my background, and I know that's instrumental to all this for many, many years, that takes on many forms also. There's broadband aspects of that, and then there's telecom aspects of that associated with monitoring and keeping the utilities and other things running under the ground. So there's this existing, if we pull back, there's this existing infrastructure that's already there. There's a need, and I'm sure we'll chat about this, for increasing that in the electrical grid and the telecom grid. And then there's all this federal funding and private money that is coming in that's going to increase our bandwidth, which is exactly what we need going forward.
When we define existing infrastructure, we can talk about what's already built, what's already in the ground, and this idea of imminently existing infrastructure, things that are planned, that are funded, that are about to go in. And so I'd love to just talk about, obviously there's what's already built, and how do we make the most out of what's about to be put in the ground? Is there a way to plan ahead better, or for policymakers to incentivize the highest use, the highest value, return on investment, whatever that looks like?
Now, to get to that, I'm going to have to tell you what distributed fiber optic sensing is. So maybe we should go there right now. So again, I've been a techie my whole life, a materials and optics guy. And most people think of optical fiber as, if they think about optical fiber, as the transmission medium for providing our broadband. You basically have laser pulses on one side. They go through this, miraculously, they go through this glass that's super transparent. They end up on the other side, they get interpreted, and that's how your internet works. It used to be copper, and there's still some copper out there, but it's becoming more and more fiber everywhere. And so the Fiber Broadband Association, which our organization works very closely with, they're all about getting fiber to as many locations as possible. The US, unfortunately, is very far behind, as I'm sure you know, in terms of having broadband to its citizens at high symmetrical data rates. So this is something we need to focus on. Where the technology gets exciting, in my opinion, is the optical fiber can function in an entirely different way that I'm going to guess that 95% or more of your audience is not even aware of. So that's why I'm excited to be here today. In addition to sending laser pulses down the fiber to be received on the other end to make the internet work, or to actually backhaul wireless, right? Because we all think about 5G, 6G going forward. For technology to work in the wireless, you actually have to have either aerially or under the ground fiber to support that, to do the transmission. If you take the optical fiber and you put different electronics on it, then you can use distributed fiber optic sensing to send laser pulses down the fiber, but instead of receiving it on the other end for broadband, you're basically interpreting the environment of the fiber such that you can identify what's happening in the environment. So, for example, I'll give a crazy example which blows a lot of people's minds. If you have fiber on one side of a road and it's being used by the departments of transportation for their own SCADA networks, or to monitor their microwave sensors or the types of apparatus, that fiber can actually hear acoustically the noise from the tires traveling down both sides of the road, and actually give you traffic and speed and congestion information by telling you exactly where the cars are traveling along the road. I hate to use this term, but it's probably the simplest one to use, kind of like a microphone. It's acting like a microphone under the ground, and it's not just where the fiber is, it's anywhere adjacent to the environment. So if you have a right-of-way, that right-of-way will interpret the tires, or it'll interpret someone opening a manhole, or it'll interpret someone using an excavator, or doing any kind of acoustically generating activity in the area.
Disruptions.
Yeah. So your question on how can we use this more effectively, and this is the thing that I'm super excited about. We're always building out new infrastructure. There's the existing infrastructure, which we call brownfield. There's the new infrastructure, which is greenfield, and it's highly funded now, and everyone wants to build this out right now. We can put it in the right place. We can put it in a location where it can not only be used for broadcom, but also be used for these other applications.
So the stuff that's already in the ground, let's say fiber optic cable that's already built, but not being tapped for this, can it be tapped for this by just existing there, or is there something that has to be added, or some new component?
Yeah, that's another excellent point. Excellent question. So there's always two sides of the coin. If it's in the ground now, I don't care if it's 10-year-old fiber, 20-year-old fiber, traditional G.652 type fiber can be used for this technology. The way it needs to be used for this technology is about every 25, 30, 40 miles or so, you need to have a rack of equipment where you're attaching the hardware and software and the lasers to the fiber. Let's say in a Department of Transportation, it's a hut. In other locations, it may be a small data center location. And so you're adding hardware and software that's been developed, and we'll get to what the Fiber Optic Sensing Organization does about that. But if it's new fiber and new conduit that looks a lot like this, right? Modern conduit that uses micro cables and puts all kinds of fiber in there, then you can actually locate it in an optimum location. So it can be used right now in many cases if it happens to be by happenstance in a good location. But going forward, and this is where, we obviously hope to collaborate tremendously with your organization. Going forward, it will be absolutely astounding if you can put it in a location where you're getting what we call multi-use applications out of it. You're not only getting the Broadcom, you're getting the traffic monitoring, you're getting the damage prevention, you're getting the bridge monitoring, you're getting the electrical grid monitoring. So going back to my organization, if I could just for a second, the Fiber Optic Sensing Association, which I encourage everyone to check out at fiberopticsensing.org, is an association comprised of all the big cable players out there, the Cornings, the Prismiums and such, but also it's comprised of the technology providers who provide this technology. This technology has been developed over the last couple of decades. It's used on border security, it's used on oil and gas pipelines, and only now is it emerging in awareness to the applications we're talking about now.
You mentioned a couple things in there that I wanted to pick up on. So there's some new components that would have to be put in place. You said that could happen at different types of facilities or points. Right. One was a data center. And I want to take a different approach to data center. So using the simple analogy, fiber optic sensing can work like a microphone, picks up the acoustic vibrations and things, but that has to be interpreted. So in obviously the simplistic analogy, yeah, we say it's like a microphone, but really it's just getting vibration data that somebody has to interpret, whether that's an AI, machine learning model, or some type of data scientist. Two questions. One, how complicated is that process? Can anyone interpret this? How readily is this data usable? And the second is, what is the data burden and the energy need to facilitate this type of I'll call it data crunching to get these interpretation usable findings? Is that going to necessitate new grid capacity, battery storage, things like that?
So those are great questions. So I'll nerd out a little bit more on the technology with you. So the way the technology works is that actually the acoustic noise travels from the source through the ground, through the conduit, plastic conduit, into the fiber cable, into the glass, and causes a micro strain. That micro strain in the glass changes the reflectance of the light back to its source. So again, as compared to Broadcom, where the laser pulses are going all the way through the other end, it's actually bouncing back, which is a natural occurrence anyway, and you're actually interpreting it. The technology is quite advanced in that there are algorithms that have been developed over time, over the last couple of decades, that interpret this information coming back. So if you're familiar in telecom, there's something called OTDR, optical time domain reflectance, I believe. That is going to give you the location. So the location on a map is identified within, let's just say 10 or 20 meters of the linear location of the fiber. What's interesting is that the technology is done like edge computing. So it's not you have to be inside the other customer's network or end user's network. Think of it as a small rack of equipment that's doing its own data processing terabits of information. And once it's processed locally there outside of the network, it then sends results across an API to wherever it needs to go. So, for example, with a DOT, it's being sent to a command control center where they're already looking at cameras, they're already looking at microwave sensors, they're already looking at induction loops. It's one more tremendous piece in the toolkit that's giving you visibility to what's going on. So how does someone use this technology? They're not going to go into the algorithms in the acoustics themselves and interpret it. They're the recipient of a location on a GIS map and an alert. And so you may get an alert that says, hey, there's digging activity occurring at a particular mile location. Is this something you want to be concerned about or not? Or there's traffic that's moving along at this location. Does this correlate with your cameras and your microwave sensors? So the first answer to your question is it's complicated at the PhD technical level in terms of what they've developed, but the end user doesn't have to worry about that at all. Now, down the road, I like to think about boiling the ocean. Down the road, in addition to the vertical markets of protecting utilities and protecting telecom and other things like that and monitoring, eventually you'll be thinking about data lakes. You'll be thinking about all these disparate pieces of information all coming together and giving you tremendous insights at a municipal level or something like that. So, and then the second part of your question, which I don't think I touched upon, remind me, Benjamin.
Yeah, so I'm just thinking all of that, I'm calling it, again, simplifying analogies here, data crunching. You said it's terabytes of information that are being processed. What's the energy intensity of that? And does it require data centers, for instance, to process, or can it really happen at a micro level at each of these kind of checkpoints?
So I'm going to hand wave since this is not, and I'm going to say no. And the
Okay.
reason is no. Think of it almost like a local computer, right?
Yeah.
That's basically just processing locally a lot of information, discarding the information once it processes it. So what's coming across either an API to a command center, or what's coming across in damage prevention, which I know is near and dear to your heart too, is SMS texts or email alerts that are, I mean, you're basically just distilling the information and you're saying, hey, boom, here's this one little piece of information, go check this out. So in terms of the input, there's not a lot of information and data.
So let's talk about use cases. So we've done traffic, how many vehicles, speed, that type of stuff. We've obviously done excavation. There's something happening, disturbance to the ground. That might be damage prevention. What are 2 or 3 or 10 other use cases? Like, what can we do with this?
Sure.
Obviously, you said security. I imagine that's a military application. Are there trucks rolling in from an enemy combatant? Maybe that's not a need, at a local municipal level. But as we strive towards smarter cities and just better communicating infrastructure, what are some other use cases?
So this will have to be podcast number 2, where we spend 2 hours on use cases, Benjamin, but I'll give you the synopsis here. So I told you it started out with a perimeter border security. Regardless of your political affiliation, which I know is coming to a head on Tuesday in the US, this technology, in my opinion, is so much more valuable than a wall in that it provides information regarding what is coming across the border, whether there's tunneling going on. Think of all the applications for technology like this that's giving you information. So that's already going on. We don't know it, but all across our nation's borders, this technology is in place.
So before we go, does that mean we literally have a virtual wall right now? Like, is that something we could say exists?
And not all linear locations, but a great percentage of it. Yes, and not only in the U.S. but across the world. So
there could be a super practical application right here where we say, federal policymakers, maybe you still want a physical high wall, maybe you don't. Wherever you land on that, you could right now say, let's put fiber optic sensing from the Gulf of Mexico all the way out past Baja California, and we would have a virtual wall that can detect trucks, tunneling, and footsteps.
Yeah, the Fiber Optic Sensing Association, one of our missions and goals through awareness is to talk to Congress and the Hill about this and the Senate. So we've already done that. They are aware of it. In fact, it's being done. And in my opinion, again, I'm a techie, right? Physical barriers are great, but they can always be cut down. There's a place for physical barriers. Let's just say there is. But a fiber optic sensing element like this, which does distributed sensing, is at worst case complementary, at best case significantly better. But this is also done, by the way, transoceanic. So you know that, well, you may not know, but all the continents are connected by fiber optic cables. And those fibers are extremely valuable because it's extremely expensive to put in fiber for long distances through continents. So they want to protect those from ships dredging up the cables or breaking them or whatever. So this technology has been focused on for that also. Where it's and also then the next one would be oil and gas. So oil and gas pipelines, right? If you have right now, there's a standard that the Fiber Optic Sensing Association developed, which actually has demonstrated how accurate and powerful this technology is. If you have a leak that occurs, I don't care whether it's a water main or an oil and gas pipeline, many cases you can only identify within a series of many miles where this leak is between the valves. If you have this running along an oil and gas pipeline now, you can identify within 10 meters that you have just developed a 2 or 3 millimeter pinhole leak that's causing an orifice noise. You better go out there and check it out, right? I mean, think about the environmental impact of not having a swimming pool of oil be dumped out before someone recognizes it aerially that you have a problem. So that's also been, oil and gas industries have embraced this. They're embracing it more. In the brownfield oil and gas, there are antiquated lines under the ground. They're degrading. So the question is, how do you snake that fiber next to it while it's live? People are looking into that so you can monitor the integrity of the existing line going forward. Now, the most exciting ones to me personally for use cases are the utility infrastructure and telecom infrastructure. All right. We work very closely with Common Ground Alliance. And I think I've already told you offline, but I'll tell your audience here about the one call system and how powerful this is to correlate it with that. So the one call system, the way that works, briefly, I'll try, is someone says they want to dig. They want to build out an open access network. They want to do some construction. They contact the statewide 811 system and they basically say, hey, this is what I want to do. And they say, hold on. Let me tell you where the maps are. Let me send you my polygons and tell you where I think the utilities are. Let me go out and mark it. You know, those are the markings that occur in our yards, right? And now go do your thing, right? In some cases, they still hit things. But in about 25% or 30% of the cases, they just don't even use the system. They just say, I'm going to do a calculation here. It's better for me to just go out there and do it. And so that's a problem, right? Because you're going to run into problems. Think about if you had fiber optic sensing technology in the right of way in critical path gas, electric, water utilities, and you're monitoring it. And what happens is, and I'm doing this with Texas 811 right now, and there are several other call centers in the U.S. very interested in this. What happens is the call center, if this technology is implemented in the utility, can get an alert that something's happening on a particular mile. They do a lookup in their system and they say, wait a minute, we have a ticket for that. It's all good. It just means your activity's starting there. You have operational awareness. Maybe it's valuable to know there's a backhole or a manhole being slid in a particular area. You know, have at it. In another situation, and that wasn't supposed to happen. And so there's going to be an impending disaster or a downtime or something cut. And so they can send an alert out that way too. My view is the emerging exciting opportunities, in addition to the proliferation of more border security, you know, more oil and gas pipelines and things, is gas, electric, water utilities.
Yeah. Wow.
How's that for a use case monologue?
Well, we've covered a lot there with just those use cases, and I know you said we could talk for hours more. I think the reason we could talk for hours more is because just discovering what the value is in each of those things, you could talk for a whole day just on you know the transoceanic stuff. You mentioned the environmental aspect. Of course, swimming pools of oil, that's a huge environmental consequence. You could talk for days on just that. And then I think about the time value of how long it takes to discover the issue, how long it takes to correct it. If you're still trying to figure out where in the linear mile it happened, that's going to take time. Then you finally identify it, then you have to fix it. Now we're thinking both the time value and the economics.
Yeah.
Fixing it, if you know exactly where it is the minute it happens, you can get there faster, save that time. The eventual lawsuit from some group who's suing you for the environmental impact, the time value that you saved by getting there quicker. I mean, we could talk for days on
Let
just that.
me add one thing. I would be remiss if I didn't mention this during our podcast. So there's accountability. And it's super important. Let's talk about the energy infrastructure just for a second, because we've been talking just utilities in general, right? Electrical infrastructure, I'm sure your organization knows, I certainly know, that with AI technology that's driving data centers, I heard a statistic the other day that something like 10 times more data center power is needed when you're doing generative AI versus other things. EV cars require substations. They require, you know, more and more of this stuff to implement the technology. But what's interesting is our electrical infrastructure cannot handle the future, right? So we're upgrading. So people are either going aerial to underground, which a lot of folks are, PG&E and others on the West Coast, and you need to have a much richer energy infrastructure. In my opinion, every undergrounding of electrical infrastructure that occurs would be remiss if they don't put in conduit and optical fiber next to it.
Yeah.
And I don't care if they're focused on Broadcom or not. I don't care if they've got other opportunities to run their SCADA, basically to protect their assets. Think about it. If you in critical long routes or moderately distance routes, if you have this technology adjacent to your infrastructure, you can not only do damage prevention, but something else we didn't touch on, Benjamin. You can do temperature sensing by a slight alteration of the technology. So yeah, I saw your eyes light up there. So
Well,
think
I
about
can think of 50
Oh yeah,
applications
so I'll tell
already.
you just a couple. So think about the optimization of the grid, right?
Yeah.
I don't When you have wind energy coming in, you've got all kinds of transfers and repositories. That gets very complicated. We're getting more and more excited about wind energy overall.
Hmm.
But there's something coming up in 2025 called dynamic line rating. And dynamic line rating means that you want to monitor the conductor temperature so that you can optimize your loads around your electric grid. There's no other technology right now that allows you using distributed temperature sensing, like distributed temperature sensing, to actually physically monitor the temperature of the conductor. So by having this technology in a slightly different variation, you can monitor conductor temperatures, you can hear cable faults before things go bad. And when you have a damage, you can locate it quickly and stop brownouts or blackouts from occurring.
Wow. Yeah, and you mentioned quickly again, it's this multifaceted thing where there's time saving, cost saving, optimization, streamlining. Yeah, it really does seem like one of those pieces of technology that more people need to know about.
Yes. What we need to do, if I could ask you, through our collaboration going forward,
Yeah,
this word has to aggressively get out more to the hill
yeah.
because we've done some work within the Fiber Optic Sensing Association by defining terms like multi-use and
Hmm.
suggesting in their documentation that they promote the use of multi-use. And that's for all the
Yeah,
reasons we're talking about here. We're going to regret it if we do a build of electrical infrastructure and
mm,
telecom and we only think about the Broadcom aspects and we go, boy, we really should have put it 20 yards to the left and we could
yeah,
have done all this other stuff, right? So we
yeah.
need to
No,
design it in now. We need to design it in now. That's my pitch.
I think that comes to the value of education where people just need to be made aware of things that already exist, not even in a
Right.
sales pitch kind of way. Just let them understand these are systems that are actually in place. Here's how
Yes.
they work. Here's what they can do. If that was all that happened, people are going to get on board with that. Enough people to move the needle. Sometimes you do need advocacy and things like that, but really just making people aware is the first huge component of it.
I'm just an
Um,
impatient person, Benjamin. I want it to happen tomorrow. That's all.
well, we'll get there. Maybe tomorrow is where it'll happen.
Yeah.
So I want to end with kind of three basic questions, maybe 30 to 60-second answers. The first is, what do you wish the average American knew in the fiber optic sensing environment or just infrastructure more broadly? What does the average American need to know?
The average American probably needs to know that our infrastructure is absolutely critical to everything we do in society.
Yeah,
And maintaining the resilience and the sustainability of our infrastructure should be a paramount concern so that we have all the life amenities and the real life capabilities that we have now. There are ways to do it. And without it getting into the technology, we have existing ways, and then we have some new ways. And we
yeah,
should design in these new ways now because guess what? The advantage of your tax dollars and your federal funds and everything else will go much further, and you'll have a safer community.
the next kind of question is, what is your message? What do you wish the key decision makers in private industry knew? In this sense, it can be any asset owner, operator. What does the business and private sector
Oh,
world need to know?
that's a great question. So people, there's a huge ecosystem for building out the infrastructure, right? I mean, we won't even go there, but there are people like my parent company who provide the products. There are people that design and install the products. The entire ecosystem needs to be aware of this, and they can figure out ways to monetize. They can figure out ways to differentiate themselves from their competition by telling the end customer, hey, I can design it in this way for you. Wouldn't you like to do this, end customer? You can get a better ROI and other things like that. So really, I have a strong desire, and so this is a pitch to your audience, to work with large utility energy providers and develop the validated business cases specific to them so they can justify internally CapEx savings, OpEx savings, life safety improvement relative to the cost of this technology. Because the business case is huge, as you might imagine, for doing this. So I'm a technology guy, so I can jump up and down all day and say, look how great this technology works.
Yeah.
But I'm also a business guy. And for this to scale, it has to make economic sense.
Yeah.
The economic sense makes perfect sense. It just needs to be validated for each entity. That was longer than 60 seconds. What's your third one?
No, that's okay, because I have a follow-up to it, which is to say something you said earlier would be my message to the business community too, and just private decision makers. It sounds like, and you can correct this, it's not complicated for the actual company who's going to be working alongside this. So in my question about does this take new data scientists and data engineers, and how much of a burden is it? Maybe a utility is going to take advantage of this technology. That utility is not necessarily taking on the burden of now
Yes.
hiring data scientists and having to hope a new wing of technical information. They can get real-time usable data that's in a format that works for them.
So you put some great time into coming up with awesome questions. so this question, yes, the short answer is for the end user and the one who's going to either benefit from a use case standpoint or financially, there's very little they need to do. Within the Fiber Optic Sensing Association, there's about at least a dozen very hungry companies who would love to do demonstrations and show the end user how this works. They would love to install the equipment. They would love to work individually on whether it's a hardware purchase or a service model, whatever works best for the industry. Let's just take a utility company. A utility company who wanted to implement this, let's say a national or global electrical company, all they got to do is they got to determine what percentage of their routes they'd like to have this on, how the business case works for them, and then ask one of the Fiber Optic Sensing Association member companies to come on board and set it up for them, provide the data analysis such that the data can feed into their system. They don't need a staff of engineers who monitor this technology. That's done by the people that produce the technology.
So I imagine that operates in some way like a subscription model that you would essentially pay for the service of usable data.
There are several ways you can slice this.
Yeah.
A lot of folks in the oil and gas industry, because they're well staffed with engineering, they say, sell me the equipment, I'll take care of it, no problem. Other folks, like probably the majority that we're talking about here, would prefer a subscription model and would prefer someone doing the the machinations for them so that they could just get the data from it.
Yeah, that's fascinating. All right, last question. Policymakers. And I think for your typical discussion, this would be federal DC level, but it can be as local as municipal level. Someone in a policymaking public role, whether they're appointed, elected, or whatever scale, what's the message that a kind of policy decision maker should
The
hear?
message is this needs to go broader than the next election cycle. So one of the San Francisco tried to do something not exactly like this, but they had geared up and then the mayor died or there was a transition and it stopped. So we need to look at the longevity of this over time. It could be a policy issue and someone can promote it, but it needs to be a long-term issue, not just for the federal government, but for the municipalities. If a government is putting in, I work closely with one of our member companies who built out Colorado Springs. Colorado Springs has now an open access provided network to it. A municipality or a state entity can look at what they're doing in terms of Broadcom, and they can say, this is how I will also additionally benefit from this technology. So design it in now, not only from a federal public policy perspective, but from a local government perspective. Be visionary about what your citizens can get by protecting your assets and by making your whole city more robust.
Yeah, and I would probably just add there, you mentioned multi-use. I think the way you craft and write legislation and regulation needs to be performance objective oriented, that it's saying achieve these types of outcomes and not overly prescriptive, saying, you know, when we do this build out has to be this way.
Oh,
We
I
want to
agree.
open it up to as many possible innovative options as
Yes,
possible. And
absolutely.
then just, that broadness of approach, not to the point of being vague, but allowing multi-use, I guess, incentivizing innovations and technologies that are going to achieve compounded results. I
That's an
just think
excellent
that's
point.
where
Excellent
decision
point.
makers need to really center their thinking
Yeah,
so
yeah,
that they don't miss an opportunity.
absolutely. And I'll just give you an example. There's a smart grant program for DOTs in the US. I think $5 million is awarded per state or something every year. For every year, I look at these smart grants and I say, please let me see one for this technology. And I haven't seen one yet. So
Yeah,
there's a perfect example of the awareness catalyzing the ability and the desire to implement multi-use technology. I don't care what it is. Maybe it's IoT devices. Maybe
hmm,
it's distributed fiber optic sensing. In my view, it's a portfolio of solutions that gives you a total solution approach and makes it more robust. So I'm not
yeah,
just pitching distributed fiber optic sensing. I'm pitching, let's use our infrastructure for more than it was originally designed to do, and let's protect it.
that's an awesome closing message. So I want to thank you for your time today. This has been really fruitful. I think there's so many things we didn't talk about that we said we could do another podcast on, and several things that popped into my head that we didn't even mention we could talk about further. But I just want to thank you for the time. Where can people find you, learn more information about you and your organization?
So you can find me on LinkedIn, and you can message me directly, or you can find me as chairman of the Fiber Optic Sensing Association, fiberopticsensing.org, or you can find me in my parent company, Duraline, and I can talk to you until you don't want to talk about it anymore, about the magic of designing in your conduit properly, in addition to everything else we're talking about here. So
Yeah,
I'm available.
that's awesome. Well, thank you again for your time, and thank you everyone for watching. We really appreciate the viewership. If you would like to learn more about infrastructure, solutions, public policy, head over to aii.org, and we would love to share our free resources with you.
Thank you so much for the opportunity, and I really enjoyed this, Benjamin.
Awesome.